Welcome and hello. This is a HEC HMS support video. And in this video, we're going to be talking about adding time bands to NetCDF metadata prior to using the importer tool. Now, the importer tool is used to convert various gridded data sets to the DSS file path format that can be used for precipitation, temperature, you name it. However, in my situation, the .nc file was not working correctly. It wasn't importing and it wasn't running in HMS. So if you're running out of ideas of how to fix your .nc files, this may be the solution for you. And full disclosure, this was not a solution that I figured out myself. It came in from Nabil, Nabil. So thank you for the question and the solution. I'm just presenting this solution to everyone out here watching the video in case you're running out of ideas about how to fix your .nc file prior to import. Okay, so let's go ahead and get started. What I have on the screen here is my HMS. Before we get started, I'm going to toggle off the discretization layer just because that takes a long time to actually resolve. And we're ready to rock and roll. Let's go ahead and check out the model real quick. Meteorologic models, I have gridded precipitation and gridded temperature. The gridded precipitation is the data set that was giving me problems. It's using a grid called precipitation. If we expand the precipitation grid, boom, here it is. This is the file. Let me expand this column here. It's in my project, data and precipitation. This is the Indus River in Pakistan, I believe. And then what we have here is the path, the first gridded data set. Now, without looking at any of the data, I'm just going to run the simulation. And then let me get the message box up here, clear the existing messages, click run. And what we have is a few error messages that pop up. I'm just going to stop it because it's error messages left and right. It says missing precipitation. And then it says each of the number of grids for each of the subbasins for every time step of the year 2000. This is a 1-year simulation, and it uses precipitation on a 3-hour time window. So period cumulative is the type, and this is a problem because if we actually look at the results here, I'll just pick this one particular subbasin graph. We don't have any of the precipitation data that we're expecting to see up here, in which case the flow at that outlet of that particular subbasin, it's just draining all the existing base flow in that subbasin. So not what we're looking for. We could take a look at the flow at the outlet for this watershed. Same thing. It's just draining the entire watershed. There's no precipitation or recharge based on the precipitation that we're expecting to see. If we take a look at the DSS data for that precipitation.dss file, I have it right here in DSS view. Part C is precipitation. Part D and E is the start and end time. And as you can see, it's a 3-hour interval. Now, if you probably noticed that it should say 3 a.m. to 6 a.m., 6 a.m. to 9 a.m. I already went through and manually changed all these, at least for a small subset, and then updated the control specification just to test 1 day or 2 days. That didn't work for me. And I thought that was a dead end, but this did look suspicious. In this precipitation data paths within DSS view, this precipitation.dss file was the output of using the HMS importer tool. I've done this myself and confirmed. So everything is looking good. We really do have precipitation data. So if I highlight all the paths and then click the plot button up here, okay, here is the projection of all the precipitation. And then if I just scroll through the 3-hour time steps, you can see we do have precipitation on the map. So if I hover over, we have 6.8 millimeters in that 3-hour time window, 2.8 millimeters, 2.4 millimeters, and so on. The watershed that we're looking at is going to be kind of right up here. That's not too important, but it is on the map. And if I look at the data, the spatial reference is WGS/UTM zone 42 north. And I've already confirmed that based on the cell size and the lower left cell and the grid extents right here, that this does properly overlap with the HMS map. So for instance, if I hover over the map here, we see the easting and the northing because we're at 670,000 easting, 3.71 million northing, 3.77 northing, and so on. So anyway, I made all those checks. Still couldn't figure out why the precipitation wasn't working for this particular model. Now on the screen is the project directory. Here's the project. We've got a few folders here. HMS is in this directory. And then the .nc files are right here. There's precipitation and temperature. Nothing wrong with the temperature, but the precipitation files, this .nc file, is the problem file. So I've copied this file. I've moved it over into a newly created scripts directory. Here's that same precipitation data file, the .nc file. And I have a couple scripts here. Print data is just going to print out the data in the .nc file because you can't open up the nc file just in a text editor. That doesn't work. That's what you get right there. But you can look at the data using a Python script and probably some of the so that's what the print data.py script does. I'll bring that to the screen in just a moment. And then the other Python script that was provided to me is this one I named add time bounds to NC file, which is going to fix the start and end part B and part B parts to the path, which ultimately is going to be adding a time step or time bound dimension to the metadata of the .nc file, which should allow the import process to work when we run it in HMS. Okay, so let's bring up the script now. Here it is. This is the first file, print data.py, and then here's the other script file to actually add the time bounds. Let's go ahead and run this real quick. This is going to just print out some metadata. So 1 second. Okay, this is just going to print out to the console down here. Okay, there we go. So I'm just going to grab this data right here, and I'm going to save it to a text file. Okay, and here is that text file. I did a little bit of work off camera, and we have our coordinates, which is time, longitude, and latitude, but we don't have a time bound. We're going to be adding that, as well as the data variable is only precipitation right here. That's fine. And then at the bottom, we should have our units for that precipitation is in millimeters. But after we add the time bounds, we should see a little bit different output when we print out Python data. So let's just put that away for now. Next, what we want to do is actually run this script, add time bounds. And what it's going to do is it's importing a few required libraries. We have an input path and an output path. So this input path is what you're going to want to change. If you want to pause the video and take a screenshot, you're welcome to. But anyway, this is the path to my problematic PR_historical 2000.nc file, my NetCDF file. Just after that, the output path is basically the exact same file path, except in the file name, I'm going to append this _ready. So _ready.nc. This is the entire script right now that I have on screen, so you can read through it. But basically what we're doing is we're adding this time band metadata to the NC file. This is not something you're going to find in the HEC HMS user's manual. It's a little bit of a non-beginner support video we're talking about here. But line 13, for instance, it specifies that the time step is 3 hours. It creates 2 different values for this new time band dimension. There's start time and end time. And those are both appended to the specific time period. So those are the bounds, which get read into time bands right here. Ultimately, line 26 creates the new CDF file based on the appended data, which is the original data set plus what we added right here, the time bands, and outputs it to that specified output path. All right, so let's go ahead and run this script. A second, let me just clear the console out. And then after running the script, what we should have is a new .nc file. It should basically be the same file as this, except PR historical 2000 ready.nc. All right, so let's go ahead and Python add and let that run. Okay, yeah, so we saw it added right over here. This is the same directory as this right here. Okay, so now what I want to do is print the data for this new file and just confirm that the new dimension for time band has been added. Let's go back to our script and then print data. Now, the only thing I'm going to do is change the file path right here. I'm going to go ready and then save, and then let's print that. So Python and then print the data. Okay. Yeah, so we have the time bands right here. I'm going to copy the entire text like I did before. All right, so right here is the Python data before and the Python data after. Now to compare these two, I will use the exam diff program. Now it wants file 1 and file 2, so let me just grab this path here, copy path, and then I want to just paste that in right here. This is the before, and I want to remove the quotes. And then after will basically be the same thing. And then I'll just change before to after. and then hit enter. It did the comparison, and you can see on lines 3 is different because before is on the left, after is on the right. Before just has time, longitude, latitude for the dimensions, but after has time, longitude, latitude, and bands. So now we have 2 bands for every time period. Line 5 through 7 have also changed to be 5 through 8. Again, we have time, longitude, latitude, and now we have the dimensionless coordinates, which is bands. For data variables, not just precipitation, now we have time bands. And there may be a few other differences here. The coloration is kind of hard on my screen. Yeah, so at the very end here, not only do we have the units for precipitation in millimeters, but now we have time bands, which is a date time data type right here. All right, so enough of that. Let's go ahead and go back to HMS and run the importer tool. So enough with the scripting. We're going to go File and then Import, and then Gridded Data, Importer. Okay. I happen to be using HMS version 4.11, but 4.12 and 4.13 are out at the time of this recording. I don't see the importer tool going anywhere. It's a very useful tool. Okay, so here is the project, and then here is the scripts. Here is the original problematic gridded data set for precipitation. Here's the corrected one after we added the time bands, and I'm going to click OK, and then next. This is nothing new. We'll click on PR for the precipitation. Here's our other variable, time bands. Next. Okay. This is using UTM version, zone 42 north, right there. And then the target cell size. Okay. And then the target cell size was actually 10,000. All right. Next. Now we need to specify the destination. So this is where we want to create a new DSS file that will contain all the gridded data sets. All right. So here is the project. Let's put this in data. So right here is precipitation.dss. This is the one that's currently being used. That's a problem. So we could just call this precipitation corrected. Sure. Then I'll click open. Okay. Parts C, D, and E will write automatically. Now for this particular data set, there was a problem with the type. So I'm going to overwrite the type and just explicitly say I want period cumulative, and then click on next. So now it's doing the processing. All right. So that finished up. Let's go ahead and click on close. Thank you. And the last thing is to actually confirm if it worked or not. So let me collapse all my subbasins here and then go to precipitation. Now we'll select the newly created precipitation.dss file. Okay, I'm in the project directory and it's in the data directory. It's precipitation corrected.dss. Select, and then right here, we'll select the first path, set path name, and save. All right, drum roll, please, and click on the run button. Okay, so these are warning messages. This deals with the storage coefficient, and that's what we had in the previous. We're not seeing the same problems that we did prior regarding missing precipitation. So we'll take a look at the results in just a moment when this finishes up. Okay, so that's finished, and it closed automatically. So let's go ahead and take a look at some data. So just maybe right click and look at the results for this particular subbasin. Boom, perfect. We have precipitation in the top plot, and then we have our runoff from that particular subbasin in the bottom plot. So that looks good. Let's check out one more. How about the outlet to the entire watershed? And look at the graph here. Yep, so it starts at about the same location, but when we have precipitation in our watershed, it gets recharged and we have flow throughout the course of the year. So that was it for this support video in HEC HMS. What we did was made modifications to our NetCDF file so that it properly imported and could be converted to a .dss file so that the precipitation actually fell on the watershed and the model ran properly.